Welcome back to Business Mathematics 2, MA1, 2, or 3. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So for today, we are going to talk about first-order difference equations. Okay, the first one, we would like to discuss about the introduction to economics dynamics. Okay, so this is the problem we face in the world. That is what determines how quickly an economy grows, what are growth rate different in different economies. Where does the path of growth lead an economy? Will a policy of persistent budgetary deficit leads inevitably to national insolvency, bankruptcy, or economic growth? Should we be using so much of our energy and mineral resources, or should we be saving more for future use? What is the optimal rate of depletion of these non-renewable resources? So this is all the problem that we will going to discuss in what we usually call economics dynamics. So economic dynamics is defined as a study of how economic variables evolve, change over time. So for this economic dynamic, we will discuss about a differential equation and difference equation. Both have economic variable that change over time. Okay, first of all, we would like to talk about modeling the time. In modeling, we have modeling time. We have two options of dating variable. That is at discrete interval of time, once a day, once a month, once a year, or continuously at every instant of time. Okay, in discrete case, we will use notation yt. So y is the variable and t is the time. T is a discrete variable, so t takes on only a whole number 0, 1, 2, 3, 4, and so on. But we cannot have y1 and a half, y2 and a half, y of square root of 2. No, because the time should be a discrete number, that is a whole number 0, 1, 2, and so on. When we are talking about the continuous case, continuous time, we will use the notation this as our variable. Y is the variable and t is the time. So this is yt, with t is a continuous variable that represents time. Okay, so the first of all, the continuous case, we will talk about what we usually call differential equation. Okay, differential derivative. And this one, discrete case, we are going to talk about what we usually mean by difference equation, discrete difference. Difference equations specify the determinants of the difference between successive values of variable. So the difference or change in the variable between two periods is delta yt. What is delta yt? That is yt plus 1 minus yt. The change of two period, that is one period apart here, t to t plus 1 period apart. So if you have an equation that involve this difference in variable in time, so you have what we usually call difference equation. So this is an example of difference equation. The consumer price index measures change in the price level of a weighted average of market basket. That is a fixed list of items in market. It is calculated monthly or yearly. If PT stands for the consumer price index at time T months, then the difference of a consumer price index, this is the difference. The difference is proportional to the consumer price index at time t. So the difference between the consumer price index at time t plus 1 with consumer index at time t is proportional to the consumer price index at time t. Okay. So this is the example of difference equation. This one also, when one deposits a fixed amount of money, a dollar, annually to a bank that gives interest R, PA, this is the interest rate. Then the deposit of money at year T, MT, satisfies, this is the difference of the amount of money between this period and the last period, is this the fixed amount for every year, and plus the interest. Okay, or I can this is the same as mt plus 1 equals mt sorry, a plus in the brackets 1 plus r of mt. Okay. Okay, so we are going to talk about differential equation now for the continuous time. Previous one, this is when the time is discrete. Time is a discrete one. So this is when time is instant time. The change is in a continuous time. A differential equation is like a difference equation that it expresses how a variable changes over time, except that time is considered to be a continuous variable. So the differential equation y has the normal form, this one. So the differential, the derivative of yt with respect to t, we can also write this, or what is dy dt, you have already know. This is the change from yt plus h minus yt divided by h. Okay, and we usually write this y prime, y dot, dy dt, the derivative of y with respect to t. This is the same. So for today, for this session, we are just going to talk about the discrete case. In the discrete case, that is difference equation. Okay. This is the example of the differential equation. So the change in capital stock market is the new investment minus the depreciation. Okay. So we are going to talk about the first order difference equation. Now we are going to talk about first. So we are going to talk about when the time is a discrete. So a difference equation can be classified by its order, the highest order of difference contained in the equation. So first order difference equation contains variable at most one period apart. This is t plus 1 and t, so one period apart. So we call this the first order. What about the second order? If you have at most two periods apart. So you have t plus 2, and at most you have t plus 2 to t, you have at most two periods. So you have second order difference equation. Okay, and what about the autonomous? Autonomous mean doesn't depend on time explicitly. So this doesn't depend on time explicitly, and this doesn't depends on time explicitly also. So what is an example of non-autonomous? This is the example because you have minus 3t. So this is depends on time explicitly. Depends on time explicitly. So linear and non-linear. What do we mean by linear and non-linear? Linear difference equation only contains term of the variable with the power of 1. With the power of 1. So this one linear, and this is linear. What about this one? This is not linear because I have the variable with the power of 2. And what about this? Log of yt minus 1. So this is not yt minus 1. This is log of yt minus 1. So it will give you a non-linear difference equation. Okay, careful, this is a linear difference equation because don't forget linear with respect to the variable, not with respect to the independent variable. Okay, so this is yt to the power of 1, yt minus 1 to the power of 1. So it is called the linear difference equation. So because all the variable is to the power of 1. We don't care about the other term. Okay. And the other one is a solution. What is a solution of difference equation? So is a function that makes the equation true. So check whether yt equals 2 to the power of t is a solution of yt plus 1 equals to yt. Let's check. Okay, so I have yt plus 1 equals to yt. The question is yt equals to the solution of star? Okay, remember again, if I would like y equal x plus 1, is 1 comma 2 a solution of this square? Yes. Why? Because if I plug in y equals 2 equals 1 plus 1. Yes, this is equals. So this is indeed true. So this is a solution of this. What about this one? What is the solution of this? The same. You want to check whether this is a solution. You substitute this into yt plus 1. So you have yt equals to the power of t. So what is yt plus 1? This is 2 to the power of t plus 1. But this is the same as 2 to the power of t times 2 to the power of... So you have 2 times 2 to the power of t. But 2 to the power of t is yt. So you have yt. So in the end, you have yt plus 1 equals 2 times yt. So it indeed satisfies this relation. So this is the solution of this. Okay, easy. Okay, later we are going to talk about the solution and its stability on the next session. Thank you very much.